Lesson 102, Saxon Algebra 1, Absolute Value Inequalities. This is going to be a rather quick lesson, I think. So the definition for absolute value is the absolute value of a non-zero real number is a positive number. The absolute value of 0 is 0. So I think we've done these before. So if you have the absolute value of -3, it's going to be +3. If you have the absolute value of 4, it's going to be 4. So the absolute value of any negative or positive number is going to be positive. And what absolute value really is the distance a number is from 0. So we never measure distances in negative numbers. They're always positive numbers. So if I said how far is -3 from 0, you would say it's 3 away from 0. Hence, absolute value is positive numbers because it's distances. So we're going to be graphing absolute values of numbers. So let's just start with example 1. Graph the absolute value of x is less than or equal to 3. So the one way to help yourself is you just pick some numbers and see what works. So if you put in a 0, is 0 less than 3? Absolute value of 0 less than 3, yep, so 0 works. If we put in a -5, -5, let's do the absolute value of -5. That would be +5, and that is not less than 3. If I put in -4, the absolute value of -4 is not less than 3 because it would be +4. So when you have the absolute value is less than or equal to a number, you're just going to put it's and equal to, so you're going to put a closed circle on 3, -3, and a closed circle on +3, and it's going to be all the numbers in between work and make it true. And you can double check yourself if you're not sure about that. Put in -2. The absolute value of -2 would be +2, which is less than 3. So all of these negative numbers that are from -3 to 0, when you make them positive, they're still going to be less than 3. And of course, 3 is less than or equal to 3, and 2 is less than or equal to 3, and 1, and all the fractions and decimals in between. That's why we color it in the whole way. Now, these are actually, there's some really tricky ones, like this one. The absolute value of x less than -4. Well, if you take an absolute value of a number, it's not going to be it's always going to be positive, and a positive number is never less than a negative number, so there's no solution to this. There's nothing that you would graph. You would just leave your graph blank. So there's no members here. It's the empty set, like this. You could put, whoops, I put in the wrong spot. The empty set, there's no solution, like that. So you just leave your number line blank, and that would just prove that there's no numbers, no positive numbers that are less than -4. You could check that out if you want to. You could put a -2. The absolute of -2 is +2, and that's not less than -4. So this one would be no solution. Another tricky one. You want the absolute value of x is greater than -4. Well, sure, any single number that you put in here is, when you make it positive, is going to be greater than a negative. So in this case, all numbers are going to be greater than -4. So we're going to color in all the numbers, like this. All the numbers are greater than -4. Tricky, tricky. Okay, let's look at the last two. Whoops. So this one is negative absolute value of x is greater than or equal to 3. So what you have to do on this, before you start, you have to isolate the absolute value, which means you have to get the absolute value by itself without the negative. So we're going to divide both sides by -1. And what happens is you're going to reverse your inequality sign when you divide or multiply by a negative. So this problem is going to end up being the absolute value of x is less than or equal to -3. So we reversed it, so what values are going to be less than -3? Whoops, this should have been a -3 to start with. Sorry, Let's put that there. I was going to say we have another problem there. So it's going to be positive, but you see how we reversed it, the absolute value reversed. So what is going to be absolute value of what numbers are going to be less than positive 3? Well, it's going to be the same thing as it was at the earlier example. You're going to fill in the circles like this and fill in between, because all these numbers, when you take the absolute value, they're still going to be less than negative 3, less than positive 3. All right, and the last problem. This one you have to isolate the absolute value. So 2 steps. Negative x is greater than, I'm going to add 2 to both sides. So it's going to be, I copied these problems down wrong both times. Negative 3. Then I'm going to divide by my negative 1. And we're going to have the absolute value of x. Now, see how we're dividing by negative? So that means we need to change the inequality sign. Is less than 3. So this is going to be the same. They don't have anything new under the sun for these examples, apparently. So this is going to be the same. It's going to be from negative 3 to positive 3. This time it's an open circle because it's not and equal to. Like that, and we're just going to fill it in like this, and that's going to be your solution. So that's pretty much all there is to this. If you have any questions, we'll go over it on class next Thursday.